calculating the median, quartiles and the interquartile range, and drawing box and whisker plots, also called boxplots. So we're going to start off by recapping a concept with which you are familiar, calculating the median average for a dataset. We will then introduce the concept of quartiles and how we calculate these as well. But we're going to start off simply with a dataset. Look at Class A. They've achieved the following results as percentage scores in a test. We're going to start off by finding the median for this dataset. So remember, the median is one example of an average. It is found by arranging your data in ascending numerical order and then finding the middle value. Now, when you have your data in a list like this, one way of finding the median is to tick off values, don't cross them out, tick them off underneath or make a mark underneath until you find the middle value. And we can see that the median is equal to 70. So there is a specific median in this example. Now let's find the median for Class B. Now, once you start ticking off values from either end, you'll notice that you get two values left in the middle. So there is no exact median. To find the value of the median, we go halfway between 62 and 66. The easiest way of doing that is to add them together and divide by 2, and that gives you a value of 64. So the median is equal to 64. Now, why did this happen? This happened because in Class A, there were an odd number of data items. There were 9 items of data, whereas in Class B, there were an even number of data items. Some of you may have used this rule to try and find the median previously. So the median value is the n plus 1th over 2 value. So you do n plus 1, divide it by 2, and that gives you the position of the median. So if we work that out for Class A, that's 9 plus 1 over 2, which gives you the 5th value for the median. And that makes sense if you count along 1, 2, 3, 4, 5, that gets you to 70. Now for Class B, if we work out n plus 1 over 2, that works out to be 10 plus 1 over 2, which is the 5.5th value, which is telling us, of course, that we are in between the 5th and the 6th value for the median. Now, let's think about quartiles and what that means. Let's go back to Class A first of all, and we can see that the median splits the data set into 2 halves. We then take the median out of the discussion, so we're no longer including the median value in either the lower half of the data or the upper half of the data. What we're going to do is take this lower half of the data and we're going to find the middle value. Now there are only 4 items of data, so the middle is going to be here, and it's halfway between 47 and 55. Now this value that is halfway between them is what we call the lower quartile. And it represents the data item that is a quarter of the way through, or 25% of the way through the data. Remember, the median is the 50% marker. The lower quartile is the 25% marker. So our lower quartile is equal to 47 plus 55 divided by 2, which comes to a value of 51. Now let's do the same for the upper end of the data. So again, excluding the median, because it's sort of like a pivot for the 2 halves of the data, we take the upper half of the data, and halfway through this upper half, we can find our upper quartile, and that's quite easy. We can see that it's just going to be equal to 81. So the upper quartile represents a 75% marker for the data. So it's 3/4 of the way through the data starting from the lower end, or 25% of the way down if you start at the upper end. So we can use this now to think of the data as 4 separate portions. We've got this portion of the data going up to the lower quartile. We've got this portion of the data between the lower quartile and the median. The next chunk of data between the median and the upper quartile, and then the last portion of data between the upper quartile and the end. So effectively, the data set is split into 4 chunks, each covering roughly 25%. Now let's do the same for class B. Now for class B, the median value was not one of the items in the data. It was halfway between two of the items. So we don't need to exclude anything. And in fact, all 5 of these values form the lower half of the data set, and all 5 of these values form the upper half of the data set. Halfway in the lower half takes us to this value here, 57, and this is our lower quartile, 57. And halfway across the upper half of the data takes us to our upper quartile, which is 79. So we're now going to introduce the next concept, which is the interquartile range. Now, the interquartile range is a measure of spread, and it specifically gives you an idea of the level of spread across the central 50% of the data. So it calculates the gap between the lower quartile in your data and the upper quartile in your data. So the interquartile range is calculated by subtracting the lower quartile from the upper quartile. So upper quartile, subtract lower quartile. So what does that mean for class A? The upper quartile is 81, the lower quartile is 51, so the interquartile range for class A is 30, which means that there's a spread of 30%, because remember the marks are measured in percentages, 30 percentage points between the lower quartile and the upper quartile. So the central 50% has that much spread to it. Now, on its own, the interquartile range doesn't always tell you very much, and really you need to compare the two interquartile ranges of two data sets to see which data set has more spread or more variation. So we're going to now calculate the interquartile range for class B. So here's the data replicated again for class B. Now remember, the interquartile range is the difference between the upper quartile and the lower quartile. So we can work out for class B, the interquartile range is 79 subtract 57, which comes to a value of 22. So we can see that the interquartile range is less for class B than it is for class A. And this means that the central 50% of the data values have less spread in class B than they do in class A. So the values are closer together within the central 50% for class B, suggesting that there is less spread or less variation in the data set or the results for class B. Now let's have a look at comparing the two sets of data in more detail. The results for class A and class B are summarised by their median and their interquartile range. If you're going to compare sets of data, a good way of comparing them can be to compare the median or average value and then the interquartile range. So let's look at class A first of all. Its median is 70 compared to a median of 64 for class B. Now it is not enough just to say that the median for class A is higher than the median for class B. That's not interpreting the data. We have to actually explain what does that actually mean. So the median for class A is higher, which means that on average, class A achieved higher results, or class A achieved better results. Now, that does not mean every single person in class A achieved better results than every single person in class B. What we're saying is that on average, class A performed better because their median, which is a representation of the class average, is higher. So we're just making a generalised interpretive statement about what the median tells us. So you've got to use some higher order thinking here. It is not good enough just to say 70 is a bigger number than 64. We all know that. That's a very basic statement. We've got to actually explain what that means. And we need to link the word median with the word average. So we need to make sure it's very clear that we understand that the concept of a median is linked to the concept of an average. Now, let's have a look at the interquartile ranges. The interquartile range for class A is 30 compared to the interquartile range for class B, which is 22. So that might be the first statement that we make. The interquartile range for class A is higher. But what does that actually tell us? What does that actually mean? Well, it tells us that the results for Class A have a larger spread. They are more varied because their interquartile range is larger. So we're going to draw a diagram to represent this a little bit later, but essentially what we're saying is if you imagine the central 50% of the data, for Class A, the gap between the lower quartile and the upper quartile is equal to 30. But for Class B, the gap between their lower quartile and their upper quartile is 22. So that means that their data has a lower spread. Now, these are not accurate diagrams. These are just quick sketches that think about the concept. A gap of 30 is bigger than a gap of 22, and a gap of 22 indicates that there is less variation, or the values are closer together within the central 50% of the data. We will be looking at a more accurate diagram to represent these results a little bit later on. So, having learnt how to calculate quartiles and recapped how to calculate the median, we're now going to look at how we can draw a particular type of statistical graph. It's called a box and whisker plot. It's sometimes also called a box plot for short. So we're going to need to use the values of the median and the quartiles to do this. And here's an example that we'll use. So these values show the number of ice creams sold in a shop over a 10-day period. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items of data, so an even number of items of data. So there is no exact median value. It's going to be halfway through. Again, you can tick off items from both ends of the data until you come to the median value. And it's in between 7 and 7, which means it is 7. So the median value is equal to 7. Now, the lower quartile, or quartile 1, can be found from the lower half of the data. Halfway through, it's simply equal to 5. So this is our lower quartile, sometimes also referred to as quartile 1. And interestingly, the median is sometimes referred to as the second quartile, because of course it's 50% of the way through the data, so 2 quartiles or 2 quarters or a half. The upper quartile is going to be 12. And of course, the upper quartile is sometimes referred to as quartile 3. So we've done what we needed to do. We've identified the median. We've identified the quartiles. We may also want to calculate the interquartile range for practice as well. So remember, the interquartile range is your upper quartile, subtract your lower quartile. So that's equal to 12 take away 5, which is 7. And it doesn't tell us anything on its own. It really doesn't. We would need to perhaps compare the interquartile range of the ice cream sold in this 10-day period with a different 10-day period to get some valid sort of comparison. So here we have the data summarised in a neat table for simplicity, and we're going to use this data to draw a box and whisker plot on the axes below. Now, make sure you listen very carefully and follow the instructions. So we're going to need a horizontal scale which represents the number of ice creams sold, and this scale must go up as high as the highest number of ice creams sold, which is 28. So I'll probably draw a scale that goes up to 30. So here we can see that the horizontal axis has been set up and labelled as well. We're now going to plot the values. Now, an interesting feature about a box and whisker plot is there is no vertical axis. There is no y-axis at all. Instead, we plot the median, the lower quartile, the upper quartile, the lowest value and the highest value against the horizontal x-axis. So I'm going to start off by plotting the lowest value, which is 2, which means I'm going to draw a vertical line here at 2. Now, the height of my vertical line doesn't matter, but I must make sure that any vertical lines I then draw match up with each other. So I could have made this shorter, I could have made this taller. It doesn't really matter because there is no y-axis. So that is my lowest value, which is 2. I'm now going to plot my highest value of 28 in the same way. So I'm going to draw a vertical line of the same height at 28. Like so. And we have our two whiskers. Next job, we're going to plot the median. Now the median is a value of 7, so I'm going to draw a vertical line at 7, which is over here. Approximately, might have to estimate just a little bit. Move that into place. So there is my median. My lower quartile is at 5. So let's draw the lower quartile in carefully. Again, make sure your lines are properly vertical. Okay. And we want to draw in our upper quartile at 12. So let's do that as well. I'm just going to move that into place. So we now have all our key values plotted. We then draw in the box part of the box and whisker plot, which is a horizontal line here that's going to join together these parts there. So we join the tops of the lines where the lower quartile, the upper quartile and the median are, and we then do the same here at the bottom part there. So we have the box part of the box and whisker plot. We then draw in horizontal lines that link the position of the upper quartile to the whisker at the upper end, like that. And we do the same with the lowest value and the lower quartile. So let's make it clear the different parts of this graph. We wouldn't normally do these extra labels, I'm just doing them for clarity so you can see exactly where everything is. So this vertical line here represents the highest value in your set of data. For us, that's 28. This value here represents the lowest value, so the whiskers. So this is a whisker. That's a lower whisker, the lower whisker. And this is the upper whisker. Now, here, and we wouldn't normally shade it in, but we'll do that just so you can see it, is the box part of the box and whisker plot. And it's noted or denoted by the lower quartile, the upper quartile, or lines representing these, and then the median. Now, why might we draw one of these graphs? Well, they give us a very good visual of the data. We can see that the number of ice creams sold varies between 2 and 28, but actually that 28 seems to be a value quite out on its own really, because most of the data, and remember 25% of the data exists between the lowest value and the lower quartile. Another 25% of the data is covered by the lower quartile up to the median. Remember, the median represents the 50% marker. And then another 25% of the data lies in between the median and the upper quartile. So this portion here represents the uppermost 25% of the data. So we can see that 75% of the data is between 2 and 12. So 75% of the data values, referring to number of ice creams sold, were 12 or fewer, and only 25% of the data items, or ice creams, number of ice creams sold, were higher than 12. So actually most of the data is in this lower tail, or this lower end over here. We also get a good visual of the interquartile range. Remember, the interquartile range represents the gap between, or the difference between, the lower quartile and the upper quartile, and is represented by this blue arrow here. A larger interquartile range will mean you have a wider or a longer box. A lower interquartile range will mean you have a shorter box. just going to label that as the box part of the box plot. So let's have a look at the data again for Class A and Class B, and this time the data has been drawn as a pair of comparative box plots, so we can instantly get some visual comparison here. So notice again there's a horizontal axis, an x-axis, which needs to be labelled as percentage score on test, so we know what the data represents. There is no y-axis. Now we can draw a pair of representative or comparative box plots on one single set of axes, which is a good way to do this so we can directly compare the box plots. Let's start by looking at the median. So we can see the median for Class B is lower than the median for Class A. Even without knowing the numbers, the visual from the box plots gives us this information. So we can say very clearly that the median for Class A is higher. So remember the comment we made previously, i.e. on average, students in Class A achieved better marks. Now it's crucial that we use this word on average, because we're not saying every student in Class A performed better than every student in Class B. It's clear that there are some very low scores in Class A and some high scores in Class B. But what we're saying is that on average, Class A performed better because their median, which is a representative of the average, is higher. Now let's look at interquartile range. Interquartile range, remember, is the difference between the lower quartile and the upper quartile, and we can see this by the length or the width, if you like, of the boxes. We can see that the box is much longer for Class A than for Class B, which means the interquartile range for Class A is higher than the interquartile range for Class B. So it's good to make an opening statement like that. The interquartile range for Class A is larger or greater than the interquartile range for Class B. But what does that actually tell us? Well, it tells us that the results are more varied or more spread out for Class A than they are for Class B. So we can refer to results being spread out, or we can refer to results being varied.